Hi, I am Rachna and this is my term project for the course Artificial Intelligence. This term project is based on a snake game. In general snake games, the player uses left, right, up, down keys to control the snake, which grows in the length when it eats the fruit, and it dies when the snake touches its own body and the wall. In this project, the objective is to apply BFS search algorithm and reinforcement learning, specifically QLearning, to a snake game and then compare their performance. This base game is taken from GitHub. When I played this game manually, my average score was around 10 to 11. Yeah, I'm pretty bad at this game. Then I applied BFS search algorithm to it, and the average score reached from my score 4 to directly 89, which was interesting. Now, the second task was to apply the Q learning, and for this implementation, the base code is used from the coursework of the University of Illinois. They have provided the basic Pygame snake and the code skeleton, in which we have to train our snake using Q learning. Then I created and updated the states and the Q table. Let's dive into the technical approach. Q-learning is a simple way for agents to learn how to act optimally in control Markovian domains. In simple terms, it uses an MDB to control and make decisions in the environment. It consists of a Q table that is constantly updated. So, I represented snake as an MDB where its state contains a tuple of XY location of walls, the location of food, and the Boolean variables to tell if there is a snake's body at top, bottom, left, and right of the snake's head. And the actions are taken, and the actions to take are up, down, left, and right. The only reward is given when the snake grabs the fruit, that is +1, and the penalty applies whenever the snake hits itself or a wall, and the penalty is -1. And if anything else happens, there is a minor negative reward, that is -0.1. That's ideal to minimize the path taken to catch the fruit and make the training process faster. We have this we have this queue function that takes one state and one action as an input and returns the expected reward of that state action pair. As we explore the environment, as we explore the environment more, Q function gives us better and better approximation of the value of an action A at state S, and then we update our function Q as we go. This value gets stored in the Q table, which became a reference table for our agent to select the best action based on the biggest Q value. Once we have a working game, we need to adjust the learning rate, the discount factor, and the settings that used to trade off exploration versus exploitation. Learning rate in this game, the learning oops sorry in this rate the learning rate is decaying, which is proportional to the number of times we have seen a given state action pair. The agent explores based on the exploration function and exploit based on the Q table. But in test phase, the agent is purely exploiting and always take the best action to give us the maximum result. These are the observations I gathered based on the different alpha, gamma, and epsilon values, and the maximum average score I got for 10,000 episodes is 27.5. And this is the final comparison between me as a human player, BFS algorithm, and Q learning. Thank you.